This is video 631, and the goal of this video is to take a look at polar coordinates and equations. So what's cool about polar coordinates is they can create the graphs that you see here that are kind of in yellow, which are actually, a depiction of what you see in the flowers below them. So we can actually create graphs like this using what we call polar coordinates and equations. So first, what is a polar coordinate? A polar coordinate is a coordinate, just like we know coordinates being x and y, where, let's just review that real quick. X and y describe how far left and right we go and how far up and down we go, correct? While polar coordinates will also tell us about where to plot a point in a graph, but it involves different items. So what we're going to look at with polar coordinates is we're going to be given r and theta. So here's what r is. R is a directed distance. We use r because we think of it as a radius. It's a distance that's from a polar center. And our polar center is the origin like we know it. So it's this point in the center here. So r is the distance from this center. So for instance, this point right here has a distance of 2 units. It's a distance of 2 from the center. So the polar coordinates of this is 2. Now the second value of my polar coordinates is what we call theta. And theta is an angle, which is why we're using theta. And it's the angle, and the way, it's kind of a hard thing to describe, but it's the angle from the polar axis to the line segment touching that point. So what we need to know is that this is the polar axis, just like we've used all year to talk about graphing sine and cosine and finding things on the unit circle. And theta will be this angle that opens up to the ray that will contain r. So it tells us how far to open up from the angle, from the axis there. So in this case, our theta would be pi over 3. So the coordinates of this point that I started with, this red point right here, are 2 comma pi over 3. Now there is a second way to describe this angle. This point, this coordinate right here. And the second way is when we talk about using r negative. So when r is negative, the point is opposite the terminal side of the angle. So for instance, the point opposite of this is right here. It's across, directly across from it, opposite of it in the opposite quadrant. Notice that this angle can be described as a negative or as a positive angle. If we describe it as negative, it would be negative 2 pi over 3. Or this angle could be described as 4 pi over 3. Again, 4 pi would be the positive angle going all the way to here. If we're going to use one of these angles, the r would actually be negative 2. So here's another way to describe the coordinates of that point. Because what we do is we open up to that angle, 4 pi over 3. So we're opening up to 4 pi over 3, which is here. And then we're going negative 2. So instead of going 2 from the origin, we're actually going to go negative 2 from the origin on that same line. This is that point that we were already talking about. These are 2 ways to talk about the point that's graphed here. So we'll work a lot with this, and honestly the negatives, you'll incorporate it after. You'll always slide it to the other side is the way I think of it. But let's take a look at graphing some points, and then we'll give you a shot on your own. So 3 comma pi over 4. So 3, so that means I'm going to be on the third ring. So here's 1, 2, third ring. I'm going to be on this ring. And I'm going to open up pi over 4. So 3 pi over 4 is going to be right here because it's 3 away. 1, 2, 3 away. And it's at pi over 4. And it's a coordinate point. So we'll label that point A. Point B is a point that is on the second ring because of 2 here. It's on the second ring, 2 away from the origin, and it's at 135 degrees. So I got to find 135 degrees, and that is on this ray right here. So it is right here, that point. We can call that B. So this is point B. And I'll leave point A on there so you can see it a little bit longer here. So A was on the third ring at pi over 4. This was A. So let's take a look at point C here. Point C is at 3 pi over 2 and on the third ring. So let's first find 3 pi over 2. 3 pi over 2 is this ray right here. And now we're going to go negative 3. So this would be 3 pi over 2 positive 3. But negative 3, we're going to go in the opposite direction. So we're going to land up here. This is point C. Kind of crazy, huh? But you'll see why we're doing this, because it creates really interesting graphs that we may use in the real life to describe different situations. So now let's try this one. Now I'm going to, again, start with my angle. Where is negative pi over 4? Well, that's down pi over 4. It's down here. This is the ray with negative pi over 4. Now I'm going to go negative 1. So instead of going 1 positive, which would be here, I'm going to go 1 negative, and I'm going to land here. This is point D. So it's important to know your angles. Again, I will give you a graph paper that's like this with these arcs and these rays. But it's important to know your angle measures. So here's your multiple choice question for this video. You're trying to find the coordinates of this point and matching it with one of these choices here. So do your best to try and figure out what that angle is. And obviously it's 4 away, but maybe it's the negative 4, so check that one out as well. So do your best to figure that one out, and then we will check your answers when we get to class. I'm going to move on now to the next part, the interesting stuff. If we're trying to graph an equation, we of course will plug in theta, as you can see, because theta is like your x, your independent variable, excuse me. So we're going to plug in theta, and we're going to find r. And we're going to collect a bunch of points that will allow us to graph a particular curve. So obviously, if we look at our graph has pi over 6, it has pi over 4, pi over 3, pi over 2, and so on. And then, of course, larger increments of that. You can't always be sure what's the best increments, but we'll take a look at and make a table, fill up this table, and then see if we can figure out what the pattern is that will allow us to graph even more and make a complete picture of this particular function. And it's not a function, sorry, I shouldn't say that, of this particular equation. Now, to get things started, I think I'm going to use the smallest unit that we see here. So I'm going to go by pi over 6. So this would be 1 pi over 6. This would be 2 pi over 6, because it's kind of just to keep it consistent and to maybe see the shape here. So I'm going to plug in multiples of pi over 6. So my next one would be 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, and so on. Now I'm at 4 pi over 6, which is 2 pi over 3, and then I'll do 5 pi over 6, and then we'll do pi, and we'll kind of see where we're at that point. Because we know that these are going to be cyclic functions, they're going to repeat themselves, so we'll take a look at how they do that once we get some of these values plugged in. So all we simply do is plug it in. 4 sine of pi over 6. So using my unit circle, you're going to find the sine of pi over 6, and that is 1/2. So this is 4 times 1/2, and we end up getting 2. So this equals 2. That's what the r is for this particular value. And I could start by graphing this if I'd like. At pi over 6, I'm at 2. Oops, I forgot to do 0. I should do 0 as well. Sorry, let me sneak in 0 down here. Let's plug in 0 as well. 4 sine of 0 will equal, let's see, sine of 0 is 0, so I'm actually going to get 0. So my first point is at 0, 0. I'm going to start here, and I'm going to land here. So here's my first and second point, 0 and pi over 6. Now I do pi over 3, so 4 sine of pi over 3. Well, the sine of pi over 3 is square root of 3 over 2 times 4. So I'm doing 4 times the square root of 3 over 2, because that's what this equals. And I end up getting 2 square roots of 3, which is approximately 3.5. So I have at pi over 3, so I'm on this ray here, I'm going to be at 3.5. So 1, 2, 3.5 would be right in here. So here's my first 3 points here. Keeping on with this, I'm going to now plug in pi over 2, so sine of pi over 2. Well, the sine of pi over 2 is just 1. So 4 times 1 is 4. So my radius is 4 at pi over 2. So I'm up at 4 for pi over 2. Now I plug in 2 pi over 3, so 4 sine of 2 pi over 3. Looking at my unit circle, the sine of 2 pi over 3 is square root of 3 over 2. Times that by 4, I get 2 squared to 3. I get the same thing I got for pi over 3, which is 3.5. So I'm going to end up at 3.5 again for 2 pi over 3. Now we're plugging in 5 pi over 6, so 4 sine pi 5 pi over 6. Hopefully you're getting the hint here. That's just fairly simple calculating, finding your values on the unit circle. This value is 1/2. If I look on my unit circle, 4 times 1/2 is 2. So at 5 pi over 6, I'm at 2. So at 5 pi over 6, I'm at 2, right in there. So you're seeing the shape, general shape right now of my function is looking like this. I need to plug in pi. 4 sine of pi is 4 sine of pi. Sine of pi is 0, so this whole thing is 0. So I land back at 0. Now I do want to check and see if this pattern repeats itself. So I would want to think about what would happen when I plug in other larger angles. So if we take a look at, we're going to look at a couple. I'm going to kind of erase this stuff in the middle here. We'll start with going a little bit larger, 7 pi over 6 down here. 7 pi over 6, 4 times sine of 7 pi over 6. Sine of 7 pi over 6 is a negative 1/2. So I'm going to get negative 2. So what that means, remember, is I go to the angle 7 pi over 6. I go to 2, but I actually want to go on the other direction to 2. Notice I'm going to land on top of where I was before. If I did this again just to be sure, meaning I check another point, I can predict right now that this function is just going to start repeating now. And it's just going to keep cycling over and over on this little loop. And I can predict that, but let's just double check it so I can confirm that. Now we're going to plug in 8 pi over 6, which is 4 pi over 3. And that's down here. The sine of 4 pi over 3 times 4 will be negative 2 square root of 3. Again, negative 3.5. So again, this one will start down here at 3.5, but then we have to go to the other side, and we're going to land up here. So this pattern is already repeating itself, therefore we are done with the function. Okay? Now they'll repeat. So we've graphed a complete function, but it lands on top of itself over and over again as we continue to plug in larger and larger values. And that's your graph. So it looks like it's a circle, and we'll talk more about that in class. If I wanted to make sure it is a circle, I would probably check some of these points in here just to make sure it actually curves out like a circle. We'll talk more about that in class, though. But your last checkpoint question is to find 3 points for the following polar equation. So any 3 points, if you want to be consistent with what we just did, you can plug in 0, pi over 6, and 2 pi over 6, or pi over 3. So plug in those 3 points, find those 3 points, and enter them in the video checkpoint. Decimals, of course, are fine.